Math 102, example 3.4.2. So once again, I would like to find the zeros of a polynomial. Now, just as before, I would like to start by listing all of the possible rational zeros. So again, P, that's everything that multiplies to the constant term. So here, that's going to be 1 and 2. Q is everything that multiplies to my leading coefficient 6. So that's going to be 1, 2, 3, and 6. So again, I'm going to put all the P's over all the Q's. So I put everything over 1. Then I put everything over 2. Again, I am going to get repeats as I make this list, so let's cross out the repeats. Then I put everything over 3. And then I put everything over 6. And there's another repeat. So there is my list of possible rational zeros. Again, that helps me narrow down what numbers are good to guess. But again, I'm a bad guesser and I'm also lazy, so let's use our calculator to help. So again, let's start by graphing that function. And again, I can use the graph to see approximately where this is crossing the x-axis. So it looks, for example, like I'm crossing at -2. So let's start by guessing -2. So again, I'm doing synthetic division with that value. And let's see what we get. That's a -12 plus 7 is -5 times -2 is 10. Add to -2, multiply to 4, add to 1, and I get the remainder of 0 that I expected to get. Now let's pause here because this function is degree 4. So that means I expect to get 4 zeros. If I take my quotient, here I've got 6x cubed minus 5x squared minus 2x plus 1. So technically, yes, I could set it equal to 0 and solve, but that's a cubic, and I don't really know how to solve cubics. So I'm going to go back to my calculator and see if I can find another 0. Looking at my picture, it looks like 1 is a good choice. So once again, let's use synthetic division. But instead of using the original problem, let's use this quotient that I just got. So 6, -5, -2, and 1. And let's see what we get this time. Once again, I do get a remainder of 0, which is what I want. So yes, that is a 0. But just as importantly, my quotient here is a quadratic. Now my leading coefficient is not 1, so I'm going to just label that A, B, and C, and let's plug it directly into my quadratic formula. So -b plus or minus the square root of b squared minus 4 times A times C all over 2 times A. So here I'm going to get 6 times 4 is 24, plus 1 is 25, and there's a 12 on the bottom. As always, if you have a perfect square, please do take that square root, which is 5. And then I need to simplify. Let me come up here. So I'll have -1 plus 5 over 12, and then -1 minus 5 all over 12. -1 plus 5 is 4, over 12 is 1/3. -1 minus 5 is -6, over 12 is -1/2. Let's pull up my calculator again, and let me zoom my window in here just a little bit so I can see this better. Oops, -1 and 1, so let's graph that again where I'm nice and tight here. Now the fractions are a little hard to see exactly, but if I look at that picture, then yes, it does look like I'm crossing at approximately -1/2 and at approximately at 1/3. So those answers do sound correct. So just to get all my answers together, my zeros are -2, +1, -1/2, and +1/3. I expect 4 zeros, and there they are.